Hello, hello, hello. Welcome to another rendition of Math is Easy, step by step. So we're getting into another GED type of question here. We got a scientific notation type of question. And this can be very complicated, but I got a test-taking strategy, almost like a little cheat I'd like to go over with you in eliminating one of these options, A, B, C, and D. But hey, let's just jump right on into the deep end of the pool and let's get started. All right, so what is the sum of 1.3 times 10 to the 7th power plus 2.3 times 10 to the 6th power? You're not allowed to use calculators for this particular problem. But don't worry, I'm going to show you how to get her done. All right, so A, option A, the answer is 3.6 times 10 to the 7th power. Or option B, 0.36 times 10 to the 7th power. Or option C, 1.53 times 10 to the 6th power. Or D, option 1.53 times 10 to the 7th power. Hey, if you want to test your knowledge, go ahead, push pause, answer this question, fast forward to the last video where I go over the answers and check your answers. If you want to go slowly with me, understand the test-taking strategies, please watch part 1, part 2, and the last part 3. I'm going to go very, very slow in explaining how to answer this question. So, again, I like to go over a test-taking strategy in order to understand how to answer how to find the correct answer and eliminate options A, B, C, or D that just do not make sense, that cannot be an answer. So first, let me just say the rule for scientific notation is the number must be between, and you got to pause. I didn't design this well enough. Maybe I did. Let's see. Okay. The number must be, so scientific notation, that number in front of the times 10 must be a number between 1.0 and 9.9. Right? That's the value right before that times 10 with the exponents. This number here has got to be between 1.0 and 9.9. Let me ask you something. Is A between 1.0 and 9.9? Yes, it is. 3.6 is larger or greater than 1, and it's less than 9.9. So A checks. What about B? 0.36. Is 0.36 between 1 and 9.9? No, that's a 0 in front of that decimal. 0.3 is less than or smaller than 1.0. Guess what? Eliminate B. The answer cannot be B. It does not follow the rule for scientific notation. All right, let's take a look at C. Is both C and D 1.53? Are they between 1 and 9.9? Yes. So C and D is possible, an option. So cross off B. Now you only have A, C, and D to choose from. That is called a test-taking strategy. That gives you 33% of a chance just to guess between A, C, and D. Now, if you had 4 A, B, C, and D and you had to guess, that's a 25% chance to guess. If you can eliminate one more, hey, that would be a 50% chance just to guess the answer right. So, it cannot be option B. Eliminate option number B. So I'd like to continue on, and what I would like to do in this next paper that I have prepared is go over some review. All right, I'd like to review with you. I hope that was a smooth transition. My goodness. All right, I'd like to review with you some key knowledge that you have to have. All right, you can only add. That's the sum, and subtract. That's the difference with like terms when it comes to scientific notation, right? Or variables as well. But what we're talking about is scientific notation. So you must have like terms. What does that mean? That means they must contain the same base value. Examples of base, 10, X, Y, Z, A, B, C, etc. Those are examples of bases. And to be a like term, they must contain the same exponential power. So some of the examples of exponential powers are here: the 2, the 2, the 5, the 5. So x squared plus x squared, right? These are like terms. They have the same variable, x. That's the letter. Variable is just the letter or symbol, represents a real number. We don't know. And they're both to the second power. So I could add 3 plus 10, which gives me 13x squared. Or another example, 10 to the 5th power plus 10 to the 5th power. Since we're talking about scientific notation, we have a value of times 10. And in this case, they must have the same exponential power in order to add or subtract scientific notation. Don't worry, I'm going to go over some examples here in part 2 and part 3 of these videos in answering scientific notation. So please watch my videos. I've created a bunch of skill videos and test question videos on many different skills. One of them is like terms versus non-like terms. Check out my video. It will be super duper helpful for you if you do that. I don't like to speed through these videos. I have a lot of information on page 3 that I have set up for you, so I'm going to stop, pause, and end this part 1 video. There'll be a part 2 and a part 3 video. Please watch the entirety of these videos in order to understand how to answer that question if you are struggling, especially if you're struggling with scientific notation. I think this is going to clarify some things. Remember, math is easy. Take it step by step. Stick around for part 2 and part 3 videos in understanding how to answer this GED mathematic test question. Thank you for joining me. Please like, follow, and share these videos. I have goals. I want to reach 20,000 subscriber, viewer, 20,000, 100,000 likes, 200,000 likes, and 20,000 followers. There we go. If I could only get my tongue out of the way of my mouth, I could talk. Woo! Thank you for joining me. Math is easy. Take it step by step.